video, we will be giving a crash course in the anatomy of a name in organic chemistry nomenclature. We are going to be following IUPAC nomenclature. IUPAC stands for the International Union of Pure and Applied Chemistry. IUPAC came in and made a new nomenclature system so that we wouldn't have to memorize a million different names. For a long time, chemists, when they discovered a new compound, they would just name it, like your parents decide on your name. And so, for instance, this compound here was named cinnamonaldehyde. Why? Because it contained an aldehyde group and it smelled like cinnamon. But IUPAC came in and said, okay, how about instead of coming up with random things that relate nothing to the structure, what if we came up with a systematic name so that each piece of the name told you how the structure was bonded together? That way we don't have to memorize a million different individual compounds. We just have to learn a set of rules, and then we can take apart this name in order to draw the structure, or take the structure and name it in a way that other people can interpret the name and know what structure it is. It's a lot like having an alphabet where you can pronounce words that you've never seen before, because each letter here has a sound to it. And so you can attempt to pronounce words even if you don't know what it is. So the basics of organic chemistry nomenclature. The first thing we have to do is find the parent chain. The parent chain is the longest carbon chain that's continuous in the molecule. So indicates the longest continuous chain of carbons. Then we will give a suffix to it to describe what is the highest priority functional group present in the molecule. In the prefix, we will label all of the branches, and so we will identify not only what the branches are, but where they are. So let's take that cinnamonaldehyde name and dissect it a bit. So in this name, it has propenal. The prop means 3 carbon long chain, indicated by 1, 2, 3 carbons here. Ene indicates that there's a double bond. Al indicates that there's an aldehyde. And so that gets into the suffix because that's part of the main functional group. This is the substituent on that 3 carbon long chain. And so that gets thrown into the prefix. This tells us that we have that phenyl group bonded to the 3rd carbon away from the aldehyde. This too indicates the location of the double bond, because the double bond started on location 2. So let's take this molecule here and try to identify what the longest chain is and how many carbons are in that longest chain. Go ahead and pause the video and try to find the longest chain. One strategy is to find all of the endpoints and then find the chain that connects them in the longest way. Okay, let's go over this. So our longest chain is going to go from here to there, to here, and then we have a choice whether to go up or down, and that won't matter in the end. I'm just going to go across. And so our longest chain has 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons in it. So when we are numbering our carbons to figure out the longest chain, these are the names for however many carbons there are. 1 through 4, you just kind of gotta learn. After that, it becomes more normal. And I say more normal because pent means, like, you might be familiar with pentagon, and then hex means hexagon, and then stop signs are octagons. So when you draw a hexagon, you'll draw lots of hexagons this semester, but kind of mimic how I draw them. If you're having trouble, you can go down, down, and then straight across, and then meet in the middle again. And that gets you a pretty nice looking hexagon. All right. The ones that everyone always forgets are hept and non, but try to remember hept and non. And then for the first 4, you just gotta say over again, meth, eth, prop, bute, meth, eth, prop, bute, until you memorize it. If you want to freak out your friends, you can just shout meth really loud, and then they'll all stare at you like you're a drug addict. But really, you're just saying it's 1 carbon long. Okay. So here are the suffixes that we're going to be using throughout the semester. We're going to start it slow and work our way up. Right now, the only suffix in your vocabulary is ane. We will introduce the other suffixes as we introduce the functional groups. So what's the name? If you think you know this, you can pause the video and write these down, and then unpause the video to see if you're correct. All right, this first one has 3 carbons to it. So meth, eth, prop, that's prop. Parent chain is 3 long, that's prop. All single bonded, that's ane. Propane. Great for grilling. This one is 4 carbons long. 1, 2, 3, 4. And so that is bute, and that's butane. Let's practice dissecting a name. So here's a name. I want you to underline the prefix, draw a box around the parent name, and circle the suffix. Unpause the video when you are ready to check your work. All right, I'm going to start at the suffix. It says draw a circle around the suffix. And that is my ane. That's a really bad X. Here is my, you can just underline draw a box around the parent name. So draw a box around the parent. And then underline the prefix. All right, so here's that molecule that we found the longest chain of before. When we do number our chain, we want to minimize the number of the first substituent. So if you remember, our parent chain came down and around like this. And so the 2 ends were here and here. And so if we numbered from this direction, our first substituent would be off of the 4th carbon. But by convention, we always start where that first substituent's number is minimized. And so it's better to number from this way. So that first substituent is off of the 2nd carbon instead. And so this carbon will be carbon number 1, and this carbon will be carbon number 2. After we identify all of our substituents off of our longest chain, we are going to be alphabetizing our substituents. So for instance, there are 3 methyl groups. And so we know that there will be a trimethyl in this name. But when we're alphabetizing, we're going to pay attention to the M. There's also an ethyl. Ethyl starts with E. And so ethyl will be listed first. We do add a Y ending, YL ending here after that prefix. So this is 1 carbon long, this is 1 carbon long, this one is 2 carbons long. And so 2 carbons was represented by eth. And so we should say ethyl. It rolls off the tongue a bit better than just meth-eth. So you'll hear lots of L's. All right, here's a practice problem for you. I want you to pause the video and find the longest chain of carbons. How many carbons? What's the name? Try to name it. And circle all the alkyl groups that come off. Before we go over that practice problem, maybe we should actually give out the full name for this molecule. So we know that this is carbon number 1. This is carbon number 2, 3, 4, 5, 6, 7, 8, 9. And so we have 9 carbons, which is non, and we have all single bonds, and so the parent chain is nonane. Then we have the methyls off of carbon number 2, 3, and 6. So that trimethyl will be off of 2, 3, and 6. The ethyl group is off of number 4. Sometimes it's hard to plan your spacing, so you just kind of have to write your name in pieces and then put it together. So we said the 4-ethyl was going to come in first. So that's 4-ethyl, 2, 3, 6, trimethyl, nonane. In this practice problem, I want you to find the longest parent chain and how many carbons are in that, and attempt to name this compound. Go ahead and pause the video, and then unpause the video when you're ready to check your work. Okay. I see a chain that goes from here down and around. So the longest continuous carbon chain I see is 6 carbons long. And so that's going to be hexane. I see a methyl off of carbon number 2. And I see a methyl off of carbon number 3. And so that's going to be, trying to find enough room to write everything, 2, 3 dimethyl hexane. So here it was. I outlined that that's a hexane and 2,3-dimethyl. So that's 2,3-dimethyl hexane. Here's another practice problem for you. Go ahead and pause the video and try to find the longest parent chain in this molecule. Name it, and then unpause the video when you're ready to check your work. Alright, let's go over this. I see a rather long chain going straight across right here. 1, 2, 3, 4, 5, 6, 7, 8. there's a branch here, that's a methyl. This is 2 carbons long, and so that's an ethyl. And then this is also a methyl. And so each carbon here is getting accounted for once. We have, if I numbered from this direction, the first substituent would be off of the third one. And so I do want to number starting from this direction so that my first branch is off of the lower number. So I am going to have a 5-ethyl in my name. And I am going to have a 2,6 dimethyl in my name. And then that's going to be octane. So if we put that all together, this molecule is named 5-ethyl 2,6 dimethyl octane. Some things to note is that there will be a dash between the numbers and then a comma separating if you have multiple numbers. There's no space here between the methyl and the octane. Another kind of trick that you can do is each carbon here is accounted for once. And so you can take apart this name to determine how many carbons are in your molecule. Being that has 8, we have 2 times 1 there. And then this is 2 carbons long. And so I have a total of 2 plus 2 plus 8. And so that is 12 carbons total. Where that line came from. So we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and verify. All right, here's a few more prefixes for you. Sometimes the substituents are not alkyl substituents. They are instead halogen substituents. And so there's different halo substituents listed here, such as fluorine, chlorine, bromine, and iodine. And so those are given the prefixes fluoro, chloro, bromo, and iodo. And so this is 2-chlorohexane because we will number from that direction. So 1, 2, 3, 4, 5, 6. So 2-chlorohexane. We can also have cyclic structures. And so this is cyclohexane, indicating that it's 6 carbons in a ring. When you do substituents off of a cyclic structure, you have to assign one of the substituents to be a number 1, and you would do that in such a way to minimize the numbering. And so we do have to be mindful of that cyclo prefix. So the hexane is straight chain. Cyclohexane is a ring structure. All right, here's a practice problem for you. Go ahead and pause the video and try to come up with the names for these alkanes. Unpause the video for when you're ready to continue. Okay, let's go over this. This first one has 6 carbons in a ring. And so I want my parent chain to be cyclohexane. I have a bromo and a chloro. I'm going to name the bromo number 1 because it starts alphabetically first. And so I'll name this 1 bromo. And then if that's a 1, then the chloro, if I number around this way, I'll minimize my numbering. Much shorter than going around that way. And so that'll be 1 bromo, 3 chloro, cyclohexane. Then here I have 5 carbons in a ring, and so that will be my parent chain for simplicity. So that'll be cyclopentane. If there is a ring, generally you want that ring to be your parent chain, and then these will be branches off of the parent chain. Makes your naming a lot more straightforward. There should only be one unique name for each molecule, so this is the proper way to do it. This is ethyl, and that's a fluoro, and so that's going to be, I'll name that one number 1, 2, 3. Go around the ring in the shortest direction to minimize your numbering, and so that will be 1 ethyl, 3 fluoro.